Hi everyone, welcome to another video from Data Stream Academy. So today we are going to talk about pages. So what is pages, right? Pages is a unit of storage which we are using in SQL. So today we are going to go into internal to understand how this is being stored, how this is like getting created, how this is related and all these things, right? Because we all know that data always stores in hard disk in 1 and 0 manner or in the digital manner. So we have also learned about every data type have a size. So when you say that you are going to store it in a page, you have a size assigned to each column. So that is going to define how many rows will get stored in a page. So we'll go into that. So what I'm doing here is like I'm creating a table called test pages. So I have an ID. So ID is integer. So integer will take 4 byte, right? And I have char of 10. So it's a fixed length. It will take 10 byte. So basically, like this table, when you think we are talking about storage, right? When you think about storage, it's going to consume 14 byte per record. So I have taken care of 10 because if you are taking varchar, it is going to change based on the data you store. So in order to keep this consistent, I use char. So I am creating this table, and I have a pre-written query. So how does it work? This gives me a couple of information about pages, right? So this is a DMDB database page allocations, and we have different various tables under sys. Okay, if you wanted to see that tables created in a database, you can use sys.tables. If you wanted to see views, sys.views are the right. So like that, whatever the like metadata of your database, right? You have system table would help you to get those information. So here we are taking such a table called database page allocation information, which will help me to see how many pages are getting created for my table, right? So we are going to see that in live. Now I have created my table. So I provided my table name here. And I'm running this. So you see no record, right? So there is no record created here. So what I'm going to do now, I'm going to insert one record in this test pages with ID 1 DSA. I don't have any index, nothing on it. Okay. So I'm running this query once again. You can see something populated, right? Some page ID 6641. So there are different types of pages. However, we can mainly talk about three types of pages today. That is IAM pages. IAM pages is nothing but it store the information about the type of pages and all these things which are going to store. So and data pages where it store the data, and we also have index pages that get created when you create a non-clustered index, and your data would be stored in index pages when you create when you create this non-clustered index. You also store those data separately, right? So we will be using the non-clustered. So here I don't have any index, I have nothing. So I inserted one record. There is one page which is allocated. There are other pages they created, but it's unallocated. That means like you're not using any storage. So now let us go into the calculation a little bit detail, right? So now how did it consume one page? I inserted one row. As per our calculation, we'll go deep into that. So one page is 8 kilobyte. That means around 8096 bytes. So how it is coming? So we have total 8192 bytes allocated, and in that 96 bytes are allocated for the header. So what is header? That means like you multiple pages, right? You will have 2-3 pages for a table. So how does it know, okay, this is the first page and this is the next page, if you are sorting it, right? In order to get that, you will have that previous page, next page related information. And we also need to know when you are going to read a page, is it a data page or IAM page or index page or whatever page, so page type. So those kind of informations are being captured in the page header. So so in out of 8192, this 96 is purely allocated for page header. So what is left is 8096. This is your 8 KB where you are storing your data. So now let us do a quick calculation about how much we take, right? So now you have 8096 byte, and I have already said while creating the table, my care of 10 is going to take 10 byte. It's a fixed length, and I have my integer that takes 4 byte. So altogether I need, in order to store my data, I need 14 byte. Maybe before I go, you might be thinking, oh, why all these things really matters, right? So I just wanted to clarify that this matters when you are going to talk about performance tuning, optimization, right? So now you know this is how your data is storing. So like, what if I use varchar? When you use varchar, it is variable length, so your storage is reducing, so you have less pages. If you have less pages, faster the read is, right? So those kind of things coming into picture. So understanding this internal will help you to have a like concrete plan while creating the indexes and optimizing the query. Clear? So now I have this 14 bytes per row, and I have also like a row overhead that they assign a 2 byte for as a row header. So what does it have, right? So this 10 4 is like what you are inserting, and this 2 byte is nothing but if there are like you are deleting the row, but that writing is not happening, but you wanted to flag it, it is deleted, right? So those kind of metadata related thing on a row level, SQL using 2 byte. So that means every row in my table is going to consume 14 plus 2, right? That means like 16 byte is required to store my one record, which I already inserted, consume 16 byte. So out of this available space of 8096, I need 16 byte per row. That means around 500, 505 or something would come all together if you are planning to consume one page, right? So I'm going to try that test right now. Now you have seen only one page is allocated, right? So I'm going to repeat this. This is how many? 16, right? So I know like I need around 500 plus in order to do that. I can select this and run it 500 times. Click, click, click. So that is a tedious task. So I'm showing you a command, like you can use this go 500. So this is going to run my statement 500 times. So let's run it. You can see that messages keep printing, so it would be 500 times. So it's going to do that 500 insert into my table. If I do a select, I am going to get this 500 records. I can show you that. 501 one was there, right? So now let us see, did it really create another page? As per my calculation, probability is less, but yeah, with the calculation I think it's 501 is consuming another page. Now you can see not just 640, 641 is also consumed. But if you read other values, right, previous file page, previous page ID, next page ID, all these things are null. So that means like 640 and 641, these two page IDs, right? IAM say that, okay, I have 640 and 641 are the pages where my this test this just the information about our test pages table, right? So test pages table has this two pages that IAM has, but these pages are not related. So if you keep inserting the data, they don't have any relation. So I'm going to add another 500 more. So let me keep it 2. Just say send to another 500 more. So let that get created. Then I can run this query once again. I can see another page is created, right? So I have 3 pages, data pages now, and I have only one IAM. IAM page will consume the high level, so it's not going to create multiple, right? So why these values are not? Because here this is a heap, right? The table is a heap. It does not have any index or anything. So that means like we don't need to know what order the data is stored, one page, page 2, page 3, we don't care, because however, like if you are going to return DSA or SAS or whatever, you have to go through all the 3 pages and read the entire data. You have no other options. Okay. So now let us see how this can be populated. Right now I have decided, let me create an index on top of this. So I'm taking an easiest path. So this is my table. I'll go to indexes, right click, create an index. I'll create a clustered index first, right? So I said it's a clustered index. I'm not going to change the pane. So I said, okay, I have this ID column. Let this be my clustered index. I'm clicking OK. So what is happening behind the scene? Create clustered index, you know the syntax, right? It is creating an index. Now I haven't inserted any extra data. I'm running this query once again. So let us see what it is changed. Now you can see the data pages are regenerated, right? Like your page ID is changed, right? So now it is 1124. This 1124 is data page 1, and you can see it has the reference telling, okay, previous file ID 1 says that, okay, do I have a previous file? The answer is yes. So that is 672. What is 672? This is your 672, right? And next is, do I have a next file? The answer is yes. What is that? That is 1025. Now, if you get this data, right, you know like what order this data is stored. So I created a clustered index. As you know that clustered index sort the actual data and store it. That's why you can only have one clustered index, but number of non-clustered index. It does not duplicate your data. It's going to use the same data but sorted in your table. So that is what you are seeing here. Your data pages are related. Now previously, like there were no relation. Now all these pages are related. You know what is previous, what is next and all. And if you scroll down, you can also see there is an index page created that is telling me like, okay, I have an index, right? So this is how this sort of happen, or like now all the pages are related. Now I'm going to do, but you don't have any data stored in index pages. So in which scenario the data is going to get stored in index pages, right? I'm going to create a non-clustered index on top of it. I already created a clustered index. So I cannot create more than one clustered index because you have seen your data pages are getting sorted. So what I'm doing, I'm going to create, I'm using my name, right, name column, and I'm creating a non-clustered index, right? So non-clustered index is going to, see this is 25 records. I'm running this again. So it become 50. So what it is there, right? You can see couple of extra pages are created, right? You can see the one which you can easily observe is there is index page that is going, that is actually storing that name related information again, right? It's a non-clustered index. So understand that index pages are used to store your non-clustered index data, because clustered index are stored in data pages in your actual data. So this index pages is having that. That's why when I created my non-clustered index, the index page is populated, and there is another IAM page giving me an additional information about indexes and everything. So the index page was already there. So this is how the pages has created that 8 kilobyte of data, right? This is how the data is stored. Like if you are trying to get the data of a table which is very large, you will be see hundreds of pages. And if you have like multiple non-clustered index, you are going to see so many index pages. So what you have to understand here, every time when you do create a non-clustered index, you have an additional set of data stored with those columns, right? So more non-clustered is every time when you do an insert, right? When I do an insert again, it has to insert into your data pages and as well as the index pages. So this also help you to decide. I'm going to do find another 500 previously it added one page, so it has to add even more pages because there will be another index page creators. And if you really look at it, there will be a slight performance degradation also you might be noticing. Here we haven't tested that because now my system has to write all this data in a sorted manner and also in my index pages, right? So that is why it is slightly time consuming. Okay, so it did not add any additional rows, but 1 2 3 4, you can see there are additional index pages because total allocation is there, but the null is reduced, so you have additional index pages created when I added another 500. Okay, so the what you have to understand, the data stores in index pages as well as in data pages based on how the indexes are created. Okay, so hope this is clear. It help you to understand what is IAM page, what is data page, and what is index page. So there are other types of pages, but just to start with, I want you to understand very fundamental that data is stored as pages, right? That's 8 kilobyte, and your 8 kilobyte is being occupied with number of rows which you are storing. It's about normal method. So how that row size is calculated based on the size of the data type. If it is in this 4 byte and small in this 2 byte, tiny in this 1 byte, right? So that selecting the right data type would help you to reduce the size of row, and that often help you to store more records in a page. That's going to help you to have an optimized storage mechanism, because if you have not a proper data type, so your data size is going to get increased, right? You have seen that additional pages getting added based on the inset. If it is not optimized, if instead of care of 10, if I would have given care of 800, even with 10 record, it would have consumed the entire space, right? So that is how this actually differs, and how it actually help you to optimize this coding. So this is how everything is stored, and we also have system tables. I'll show you a system table, and we'll conclude this video. And is sorry, I don't want to lose this query. Select star from sys dot. So yeah, if you put sys dot, you can see sys dot all object will give you everything. That means this is stored procedure is in this this database, which is the DSLN database. You will also be able to see SP underscore are most of them is system stored procedure. They also have system stored procedure, which will help you to get. So you can see view stored procedure, extended stored procedures. You will also be able to see tables below. So everything you can see, and yeah, you can see view system table. So these are system table. So if you explore this, you will be able to understand a little more about internals. And if somebody wanted to see all the tables, you can just run a query about sys tables. And you know these are the three tables, right? These are the three user defined table. When you give all, you are going to get system as well, because here we don't need system, right? And if you give sysviews, I believe we have sysviews. Yeah, I don't have any views. Yeah. But when I have typed view, you can see three: all views, and their system, and these things, views and system views. So you can choose what you need, and you will also be able to get the execution plan related information, this internals, how this is stored. Everything is stored in SQL, captured in a table. And if you wanted to get the database level information, as I have mentioned in our initial fundamentals session, you would be able to get those information in your system databases. Hope this is clear, and you are able to understand how pages are working. I have mentioned in some of my posts and everywhere data is stored as pages. Now hope this video helped you to understand how this is. We'll be talking more about other functionalities and all these things. We deep dive into the SQL functionalities in upcoming videos. Thank you.